And let us pray. In the name of the Father, and the Son, and of the Holy Spirit. Amen. Saint Michael the Archangel, defend us in battle. Be our safeguard against the wickedness and the snares of the devil. May God rebuke him, as we pray. Then do thou, O Prince of the heavenly host, by the power of God, cast into hell Satan and all evil spirits who prowl about the world seeking the ruin of souls. Amen. In the name of the Father, and the Son, and the Holy Spirit. Amen. All right, Dempsey. There was a worksheet I handed you all out. This was 7 something or other. And I handed you the first half.
It's 13N-1.
Oh, 13. Wow, I remembered that.
And there's an N too.
Oh, yeah, sorry. I had copied and pasted the wrong title. By the way, y'all are not algebra 2 either. It's supposed to say breakout. I was making like 4 worksheets on that day, and I was copying and pasting the titles and got a little carried away. So yeah, it says you are still in breakout. Let me see what you got.
I do not understand how to figure it out. I tried, but I think I'm figuring it out.
This is homework. It's supposed to be 7D-1.
13N-1.
Yeah. Fixing it up right.
It made me feel smarter until that number was higher. Probably just mine subconscious.
I like work. All right.
Okay.
Wow. Real sex. Thank you.
Alrighty. Grab a red writing utensil. Space front clear. The answers are as follows. Number 1. There are 4 angles. These are all in degrees. So theta equals 0, 45, 135, 180. Degrees each of them. Number 2, 4 angles. 45, 90, 135, 270. Number 3, there are 3 solutions. 0, 90, and 180. Did we repeat something? Yeah, sorry. Number 1 was 0, 45, 135, 180. Number 4 solutions. 60, 90, 120, 270. Number 5, 4 solutions. 0, 120, 180, 300. And number 6, 4 solutions. 0, 135, 180, and 225. It repeats the whole thing. Yeah. Number 2, 45, 90, 135, 270. Yeah, there's so good. 6, 0, 135, 180, and 225. These are all degrees. And the others. Alrighty. Yeah.
I have all these homeworks you can check out.
Oh, yeah, please. Yeah, so A, and that's 7B, yeah. 7C. This, I think, was in 2 parts. This is in 1 part. All right. Thank you. All right, questions? Maybe you want to see dissected?
Yeah, can you do
Yeah. 4 sine squared of theta. Equals sine of theta. Plus 3 sine squared of theta. First of all, can I solve with algebra? Why not? Yeah, there's 2 different species of sine. And by the way, if you have sine and you have cosine in the same problem, that's also 2 different species. So this, I cannot solve with algebra. What must I do immediately? Yeah. Set it equal to 0. You can either set the left is equal to 0 or the right equal to 0. Doesn't really matter. I'm going to set the right equal to 0 just to show you. I'm going to subtract sine of theta on both sides. And I'm going to subtract 3 sine squared. So these cancel, So you're left with blah, blah, blah equals 0. You notice 4 sine squared minus 3 sine squared is 1 sine squared. And then this will be minus sine of theta. Does that make sense? Right. This can factor. Well, not that. Michael. What do you always try first? Is there a GCF?
Yeah.
Of what?
Sine.
Sine of theta. Correct. If you pull a sine of theta out in front, what's left behind? So this is basically sine times sine. So what?
Sine theta.
Okay. Minus what?
1.
1. Good. Is everybody okay with that step? See what I did? It's basically like x squared minus x. You pull the x out in front, and it will be x minus 1 left behind. Now, this is the zero product property. So either sine of theta is equal to 0, or sine of theta minus 1 equals 0. And these you can do separately. I'm going to add 1 to both sides here. Because you want to get the trig function by itself. Sine of theta equals 1. Let's try this one. Sine of theta equals 0. Does that ever happen? Think a unit circle. What is sine in the unit circle? Height. Does the height ever equal 0? Yeah, at 0 and at 180. Let's write those down. Next. Does sine of theta ever equal to 1? At 90, and that's the only place. And you are that. Make sense? Yeah. Yeah. Does it make sense? Everything number 3? Did you recreate that on that? All right. 6. Sine of theta plus 2 radical 2. Let's write this first. Plus radical 2 sine theta cosine theta equals something. 0? Okay. What would you recommend? Can I solve with algebra? No. I've got 2 different species. 2 radically different species, sine and cosine. So we got the answer to 0, which is good. Wait, what would you do on this thing?
Well, you could pull out a GCF of sine theta.
Yeah, it is the GCF. Pull sine of theta out in front. What's left behind?
1 plus radical 2 cosine theta.
Correct. Just make sure the cosine isn't underneath the sine, radical 2. Now what? Sophie, what do you do with this thing? Yep. Or? Correct. Okay, subtract 1. Yeah, radical 2 cosine of theta is negative 1. Then divide by radical 2 on both sides. So cosine of theta equals negative 1 over radical 2. Can you fix that for me? It's negative something. Where? So cosine of theta is negative radical 2 over 2. So question, Noah, common or uncommon?
That's common.
Common. Multiple of 30, 45, or 90?
Right. 45.
I'm sorry, 45, correct. Where?
So it's going to be 135 and 245.
Yeah, cosine is left right and it's negative, so go to the left. So 135 and then what? Sorry?
225.
Correct. 135, 225. Those are the solutions from this one. Can somebody give me the solutions from this one? Michael. When is sine equal to 0? Think of unit circle.
0 off, so
Zero.
it's 90,
90 would be sine of 1.
or not 90, just 0. Or,
I'm sure there's one of there. Here's 0.
no, like 0, yeah, 0,
That has a sine of 0. There's
Yeah.
one other place that does.
180.
180, correct. It also has 360, but that's outside of our boundaries. So you have 4 solutions: 0, 180, 135, 225. Next. Any others? Number 1. Yeah, negative sine of theta. Can you read it off for me?
Negative sine of theta plus radical 2 sine of theta squared equals 0.
Okay. What can we do with this monster?
So you got a GCF of negative sine of theta.
Good. Take out the negative sine of theta as a GCF, because it starts negative. What's left behind it?
1 plus radical 2 sine of theta
Actually, pull the negative.
minus
Minus radical 2. And then regular sine of theta. Yeah. Does that make sense? Now what?
0 product of
Yeah. So negative sine of theta equals 0. 1 minus radical 2 times sine of theta equals 0. Solve this one for me.
just 0.
Yeah, divide by negative 1, it's still 0. So sine of theta equals 0. When is sine of theta equal to 0?
At 180 and 0.
Yeah, at 0 and 180. We got 2 of our solutions. Let's go for this one. This should actually look kind of familiar. Minus 1. It's okay. So negative radical 2 sine of theta equals negative 1. Okay. Correct. Divide by negative radical 2 on both sides. The negatives cancel, cancel. So sine of theta is equal to what? Good. 1 over radical 2 is just radical 2 over 2. Common or uncommon? Multiple of 30, 45, or 90? 45. Tell me which ones they are. 45 and a 135. Correct. Because this is sine is height and this is positive, so it's going up. So the only 2 multiples of 45 are up here. Here. Gonna get this? All right. The rest of the worksheet on the back side is very, very much like the front. There aren't any real new tricks, just more stuff. I do want to give you a little bit of new notes as a teaser for tomorrow's stuff. This sort of stuff, there was a little bit of it in second year algebra. I'm about to go beyond that. It's not horrendous, but it's something that the 10th graders did not see. Just as a quick example, I'd like you to solve for theta from 0 to 360 degrees. This is just a review problem. Sine of theta equals 1/2. So hopefully this should not stress anybody out. Good old fashioned, nice easy one. Now, common or uncommon? What do you think? Good one. Common. What shape is it reminding you of? 30, 60, 90, 45, 45, 90, unit circle.
Unit circle?
Like, that's true all the time, that's always safe to say.
45, 45, 90?
What are the sides of 45, 45, 90?
Oh, I don't remember.
Those we'll need. So 45, 45, 90. What are the sides of the 45, 45, 90 triangle? Yeah. 1, 1, radical 2. Memorize those. And then the 30, 60, 90? What are the sides of that? Remember those?
1, 2,
Correct. 1, 2, radical 3.
so what, that's right?
So which shape is it coming from? If it were 1 over radical 2, it would have come from 45, 45, 90. Because there's a 1, there's a radical 2. But there's no regular 2 in here. However, there isn't 30, 60, 90. So it's a multiple of 30. So, where are we? Anybody? It's a multiple of 30. What is sine again? Is it up, down, left, right, or slope? Up, down. Is this up a lot or a little? A little. So it's a multiple of 30 and it's only up a little. Where are we? 30? And where else? What is the same height? 150, correct. So you've got solution of theta equals 30 degrees, theta equals 150 degrees. Now, that's a review problem. Hope everybody's okay with that. The book is going to start doing something a little different with the interval you want. First, a piece of notation. Can anybody tell me what this sort of funky looking E means? Yeah. Belongs to. So theta belongs to the interval between 0 and 360. I'm about to change that. I'm going to use the exact same problem. Sine of theta equals 1/2. So you should be able to just look for know where to look for the solution. Write this down. Capital R. What does that mean? At the beginning of second year algebra, we have, and actually possibly at the beginning of this year we reviewed it, but definitely at the beginning of last year, there were a bunch of categories of numbers. There was natural numbers, whole numbers, etc., etc. Does anybody have to remember what capital R stood for? Rational is a good guess, although that was Q.
Is it radical?
No, radical is, yeah, good guess again. Those are irrational. Real numbers.
Oh,
This is all real numbers. In other words, I don't just want the solutions once around the circle. I want them all. There's an immediate problem. Let's try this. Before we go too far, does anybody happen to remember what this symbol means? It's like a triple equal sign. Reduced it the other day. What does this thing mean? Kind of. Actually, that is actually what it is in college. Yeah. Coterminal. Coterminal means they're in the same spot. They end in the same spot. So, for example, 30 degrees. Can somebody tell me an angle that's coterminal with 300? Why did I do that? 30. It's not 300 level. P.
150.
150 is over here. It's a different spot.
So 390.
390. Nice. That's in the exact same spot. Give me another coterminal. No.
So 390 plus 360,
Yes.
which is 750.
Correct. 750. And then it keeps going. Can nobody go backwards? What's a coterminal before 30 degrees? If you go into the negatives. So it goes like -90, -180. Where would this be? Michael. Close. -3.
20, 330.
-330. Yeah. Basically, you add or subtract 360 to get to where you want. If you want to get another one, negative 690, I think. Keeps going, blah, blah, blah. How many angles are in this spot? Just this one. Infinitely many. Yeah. And I'm asking for them all. We've got a serious problem here. I'm just asking you for an infinite number of angles. You do not have the time to give me an infinite number of angles. By the way, you also have to do the ones over here. What's 150 plus 360? 510? Somebody check my math. Blah, blah, blah. And then the one before that is negative 210. Blah, blah, blah. So you have two strings of infinitely many angles. How in the world are we going to do that? Allow me to introduce you to the letter K. K stands for a constant. A constant number, like 3 or 20 or something like that. Can somebody tell me what this means, thinking back to last year? R is the real numbers. So we have to remember what Z stands for. Go.
The integers.
Those are the integers. This means K belongs to the integers. What are the integers? Pete. What are the integers?
You got 1, 2, 3, and then isn't 0 part of it?
0 is part of it, and a few others.
And it's just, does that include the negatives?
It does. So dot, 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 negative 2, negative 1, 0, 1, 2, dot, dot, dot. The integers are all the round numbers, positive, negative, and 0. The whole numbers are 0, 1, 2, 3, 4, 5, 6. And the natural numbers are just plain old 1, 2, 3, 4, 5, 6, and so on. Okay. So the counting numbers are the positives, the whole numbers are 0 and up, and the integers are positive and negative. Okay? Why do I bring this up? Well, do you notice, let me just highlight these. Do you notice this is 30, and this is 30 plus 360, and this is 30 plus 2 360s. If you kept going, 1080, I think. Blah, blah, blah. It would be 30 times 3 times around the circle. Does that make sense? So every time you need a coterminal, you just throw in another 360. The formula we're going to use is 30 degrees plus 360 degrees times K. In other words, you can multiply 360 by any number you want. Times 1, times 2, times 3, times 4, times a billion, times a trillion, times negative 5, times negative 6. You can go forward or backward, but you have to put this in parentheses. K belongs to the integers. This is going to be the key to the next homework. This includes all the repeats, coterminals. For 30 degrees. If you want all the repeats, tack this thing on the end. Here's the original angle, plus 360 degrees K. And then make sure you put K belongs to the integers. Why are we insisting that K is an integer? Like, why not let K be anything you want? Yeah.
Well, that can mess up the kind of ratio. It's like 1/2. That'd be
Yeah.
80. It'll be
If you try 1/2, you won't get all the way around the circle. You'd end up here, halfway around the circle, and that'd be wrong. I want to end up in the exact same spot. So I've got to get a whole multiple of 360, which means I need a whole number, or an integer in this case. Does that kind of make sense? So, what about this thing? Look at the two angles we have so far. Can you give me the solutions for all real numbers? Now you have to do two different chains, one for 30 and one for 150. So solving for theta is this, ta-da. But for theta is all real numbers, in other words, every single one of them, what would you write? You're feeling great. First of all, what angle is the base angle here? Like, what angle definitely works? Give me one angle that definitely works.
30.
Third. How do you get all of its multiples or coterminals? Plus what?
360.
360 times what? Because this will just be once around the circle and you're done. How do you keep doing times 2, times 3, times 4, times 5, times whatever? What do I put here? Look over there. Count. Copy and paste.
30.
360 degrees times
K.
K. In other words, a variable. This will be 360 times 1. One's around. 360 times 2. 360 times 3. That'll cover everything. But you have to tell me that K is a what? Not a real number, but integer. That's half of your answer. See, can you give me the other half? It's almost identical.
So it would be
This stuff will never change, by the way. It'll be forever and ever the same. Theta is what?
equals 150
150 degrees plus.
360K.
Yep. You do not have to change a single thing about this ending formula, where K belongs to the integers. This is a solution. Yeah.
Wait, so that solution includes the numbers?
This will include absolutely all the multiples. This just includes the first two. I'm sorry, what was your question? I don't know.
Does that include all the negatives?
Yes, it does. Because K can be an integer, so if K is -1, it'll be 360 plus -360, or 30 plus -360, which I forgot what it was. -330. So we did that. So if you start plugging negative numbers in for K, which is allowed, you can do negative integers, you'll start going backwards and catching all those. So yes, it is safe. Does that make sense? So in other words, you just have something to memorize. This thingy, this tagline at the end, captures all the repeats. And that will never change. You do not have to do 180, you do not have to do 90 or anything like that. It's always 360 degrees K, but specify that K is an integer. That make sense? That will capture every single repeat you ever want. Let me try one more. Tangent of theta equals negative radical 3/3. And I want to solve for every single answer that exists. Solution that exists. Can somebody talk me through it? So they start me off. First of all, does this look common or uncommon? Common. Multiple of 30, 45, or 90? 30, because these come from the 30, 60, 90 triangle. Where are we? What is tangent on the unit circle? Slope. Positive or negative slope? Negative. A lot or a little? A little. What would the lot be? Radical 3, correct. So if it's a little, where are we? Yep. 330. Can you give me the solutions? Theta equals what? And theta equals what? Do the first one. Definitely start with 150. 260 degrees K. And then K must be, yeah. In one of my previous schools, everybody got fascinated with this. They started calling it CADS. That's not really what it is. But if it helps you remember, hey, go for it. I had some people who were just utterly and completely lost, but as soon as they got to this, CADS! I hope you remember how much that. And then what's this? Go for it. Exactly. Take the base angle and
Let's do 60.
do 60 degrees K, where K belongs to, and which stands for the integers. So that's your final solution. Make sense? In other words, this was what we were doing before. Those are the first two solutions. That's just once around the circle. And then this is going around the circle forever and ever on minutes. This would capture all the repeats going forward and all the repeats going backward. Okay? The assignment I'm going to give you tomorrow is going to be using this. But the one for today, you should have the notes to do that. Still more factoring. You've got about 22 minutes to do that. The rest of the hour is yours. So go to it. Call me if you get stuck. Otherwise, enjoy. And for those listening at home, God bless y'all. Get well soon, Jenna, and the people who are doing retreat stuff. God bless your energy. See ya.